Hi, hello everyone, how are you? My name is Hitesh Reddy Tipasani and today we are going to dive into the world of distributed databases. Specifically, we are looking at a powerhouse in the industry called Apache Cassandra. If you have used Netflix to watch movies or scroll down through Instagram or listen to playlists on Spotify, you have already interacted with Cassandra. It is the engine running behind some of the most data intensive applications on the planet. Over the next 15 minutes, I'll explain what it is, why the tech giants rely on it, and how it differs from traditional databases that are used. Let's start with where this all began. The story of Cassandra starts at Facebook in the year 2007. Back then, Facebook had a massive problem. Their inbox search feature was crashing under the weight of millions of users. They needed a database that could write data incredibly fast and never go down. So two engineers named Avinash Lakshman and Prashant Malik built Cassandra to solve this. They named it after the Trojan prophetess from mythology, Cassandra, because in the early days of NoSQL, no one believed that a database without a central master could work. They proved the skeptics wrong. In the year 2008, Facebook open sourced it. By the year 2010, it became a top level Apache project. Soon after, the company called DataStax was founded to provide commercial support, which really pushed Cassandra into the enterprise world. Today, it is no longer just used by Facebook as an experiment. It's a mature technology used by thousands of companies. You will find Cassandra wherever uptime and scale are non-negotiable. Social media giants like Facebook and Instagram use it for messaging and tracking user activity because it can handle millions of writes per second. Entertainment platforms like Netflix, Spotify use it for recommendation engines. When Netflix remembers exactly where you paused a movie or Spotify suggests a new song, the data is often being pulled up from Cassandra. It is also huge in e-commerce companies like eBay. Macy's use it for shopping carts and transaction histories, and in financial services like Capital One, where it powers fraud detection systems that need to analyze transactions in milliseconds. Now let's get technical. What exactly is Cassandra? The formal definition is that it is a distributed NoSQL database management system. But what does that actually mean? Most traditional databases we learn are about relational databases like SQL Server or MySQL. They live on a bigger server. If you need more power, you buy a bigger server. But Cassandra is different. It is distributed and masterless. Imagine a peer-to-peer network. There is no single boss node. Every node in the cluster is equal. That means there is no single point of failure. If one server goes down, there is something server like an server that instantly takes over the previous server. It is designed to scale horizontally. Instead of buying a bigger and expensive computer, you just add more cheap commodity servers to the cluster. It combines the best architecture concepts from Amazon DynamoDB and Google's Big Table to create a system that is practically impossible to kill. Let's look at it how it stores data because this is where it gets really interesting. Cassandra uses a wide column store model. In traditional relational database, you have a fixed schema. If you want to add a new column in the table with a billion rows, you might crash the entire database. But in Cassandra, schema is dynamic. You have different columns for different rows. You can change the schema on the fly without downtime. The structure is hierarchical. That means you have a key space, which is like a database container. Inside that, you have tables, then rows, then finally columns. Under the hood, it uses something called LSM tree or long structured merge tree. I won't bore you with the math, but the takeaway is these LSM trees are optimized for writing data. This is why Cassandra is so fast at ingesting data. It writes sequentially to disk rather than jumping around randomly like a traditional database, how it often does. One of the best things about Cassandra is how accessible it is. You have three main ways to use it. First, There is an open source option. It is completely free. You can download it right now and use it on your laptop or deploy it to your own servers. You pay zero licensing fee. Second is for big companies who need insurance. There is a DataStax Enterprise that is commercial version. It comes with 24/7 support, advanced security and analytics tool. Third is modern way is the cloud database service, which is specifically like an Astra DB. This is fully managed. You don't have to worry about your servers or updates. You just pay for what you use on AWS, Google Cloud, or Azure. It is fully compatible with Kubernetes and Docker, making it perfect for modern cloud native applications. Briefly on pricing, it follows the model of pick what fits your budget. If you are a startup or learning, the free tier open source is perfect for you. Your only cost is the hardware you run it on. If you are a cloud first company, you can use the pay as you go model with Astra DB. You are billed per write and read. And if you are on bank or a massive enterprise, you can go with the custom pricing from DataStax to get that guaranteed support and service level agreement. Let's talk about power. How much data can this thing actually hold? The answer is virtually unlimited. We aren't talking about gigabytes or terabytes. We are talking about petabytes. Let's take Netflix for example, it stores exabytes of data. Cassandra scales linearly. So if you double your servers, you double your capacity and through output. It is incredibly efficient. So it compresses the data on the disk, often reducing the size by 50% to 80%. So a terabyte drive might actually hold 16 terabytes of real data. But my favorite feature is the durability. By default, Cassandra replicates your data 3 times. So if you write a piece of data, it copies the data into 3 different servers automatically. So you could literally walk into a data center and smash a server with a hammer and still you won't lose your single byte of data. That's how Cassandra works. How do we talk to Cassandra? We use a language called SQL or Cassandra Query Language. If you know SQL, this will look very familiar. You have select, insert, update statements. The syntax is almost identical. However, this is a big however, like it does not work exactly like SQL. In SQL, you join the tables together. You can say grab this customer and join it with the other orders. But unfortunately, Cassandra does not support joins. This is a deliberate design choice. Like joins are slow and expensive in a distributed system. In Cassandra, you have to design your data around your queries. So if you need to look up a user by email, you create a table specifically for that. It requires the mindset shift. We call it query first modeling. This brings us to usability. I'll be honest. Cassandra has a steep learning curve because it looks like SQL. Developers often try to use it like a relational database, and that causes a huge problem. You have to understand concepts like partition keys and consistency levels. But once you master it, it gives you superpowers. It gives you control over a massive distributed systems and you just can't get with other tools. It demands an experienced team, but the investment pays off when you need a scale of such kind. I want to highlight a few advanced features that really set Cassandra apart. Number one is multi-data center replication. You can have one cluster that spans entire globe. You can write in New York and you can have it instantly available in London and Tokyo. Suppose if New York data center goes offline, due to hurricane, the traffic automatically shifts to London. It's and active everywhere. The number two is tunable consistency. In most databases, consistency is binary. It's either consistent or it isn't. But in Cassandra, you get the choice, so you can choose. Suppose for banking transaction, you can say, I need all the servers to agree before I confirm this. But for social media, you can choose it like, I only need one server to acknowledge this. Speed is more important than perfection. So you get to tune the dial between speed and accuracy for every single query on Cassandra. To summarize the big wins, let's see the points. Horizontal scalability. You can scale infinitely just by adding a few nodes to it. And extreme write performance. It is optimized for writing data fast, like millions of operations per second. Next point, high availability. There is no single point of failure. It is always on. Next is global footprint. It is built for the cloud and multi-region deployments from day one. Next, cost. Because it runs on commodity hardware and is open source, it is often much cheaper at a scale than proprietary options like Oracle. So it has its features and advantages in Cassandra. As we know, no technology is perfect. We have to be realistic about trade-offs. Cassandra is not a general purpose database. No joins, as I mentioned, you cannot join tables, but you have to denormalize the data. Limited analytics, you can't just run a complex group by query to analyze your sales for the last year. Further, you usually need to pair Cassandra with another tool like Spark. Eventual consistency. By default, Cassandra is eventually consistent. That means there might be a delay of a few milliseconds before all the nodes have the latest data. For some applications, that's a deal breaker. If you have a small data set and need complex reporting, stick to relational database. But if you have a massive data and need speed, you can choose Cassandra. If you want to learn more, I highly recommend you to check out the official Apache documentation and the DataStax Academy, which offers free courses. There is also a vibrant community on Stack Overflow and GitHub if you get stuck anywhere while learning Cassandra. To wrap this up, Apache Cassandra is the heavy lifter of the database world. It powers the apps that we use every day by prioritizing scalability, availability, and performance. Thank you for your time. I'm happy to take any questions you might have, and you can also use the comment sections if you want to ask any more questions about this.